Hi friends, welcome back. Today we are going to solve Codeforces problem Kuriyama Mirai stones. So before we look into this problem details and the solution for this problem, I just want to mention that my channel is dedicated to help people who are preparing for coding and Java interviews. On my channel there are over 200 solved different varieties of problems, and those are coding questions which were taken from previously asked interviews by big tech companies like Amazon, Apple, Google, Microsoft, Facebook, Yahoo and many other companies. And those are selective problems to cover important coding questions varieties such as dynamic programming, graph questions, binary search tree related coding questions, BFS, DFS matrix related problems, as well as priority queue related optimizations problems. There are other questions related to linked list and string coding questions as well. So if you are preparing for Java coding interviews or any Java interviews, then this channel can be definitely helpful in your Java J2E interview preparations. So please subscribe to this channel. So now let's look into this Kuriyama Mirai stones problem. So Kuriyama Mirai has killed many monsters and got many, namely N stones. She numbers the stones from 1 to N. The cost of the ith stone is VI. Kuriyama Mirai wants to know something about the stones, so she will ask you two kinds of questions. So these are two kind of questions. She will tell you two numbers L and R, such that L and R is between 1 to N, right? And you should tell the sum of VI between that L and R, right? Including L and R basically. So you have to do the summation basically from L to R. And the second question is, let UI be the cost of the ith cheapest stone, the cost that will be on the ith place if we arrange the stones cost in non-decreasing order. This time she will tell you again two numbers L and R, and you have to again tell her the sum, but this time she has arranged the stones in non-decreasing order, right? And this time, first time it's not arranged, but second time they are arranged in non-decreasing order, right? So for every question you should give the correct answer. So let's look at the inputs that's given to us in this question. So 6 is given. So 6 is the here 6 is uh, a line that contains integer n. Second line contains n integer. So 6 are the stones, right? These are the stones, and this is the cost for this each stone, right? So 1 2 3 4 5 6, and then 3 are the next line contains integer m. These are the Kuriyama Mirai's three questions, right? So this is the type 2 question. This first thing is a type, right? Type 1 or type 2. And the second is the L, and third is R, right? L and R is given, right? Left and right numbers are given to us basically, right? As you can see here, this L and R is the left and right number for which we have to do summation, right? So let's just take this first problem, first example over here on the whiteboard, so we can understand this problem better here. So as you can see, this is the array. These are the value of the stones which is the given to us, right? Is the array is given to us. This is the input array. So first type of problem, for example, she will tell us, like let's just consider the first example here. So she will tell us left and right, right? First, this is the type 1 problem. So if L is 3 and R is 4, right? L is 3 and R is 4. So let's just write down here. So type 1 problem, right? Type 1. So type 1 problem is there where left is 3 and right is 4, right? Right is 4 here. So we will go to 3 and 4 position here. So 1 2 3 and 4, right? So 3 and 4 position we will go, and we will do the summation of this one. So 2 plus 7 is 9. So in this case we will return 9 as the answer, right? So let's go to the second one. So 9 is the answer here, as you can see it. Now the last is again type 1 question, and this time L is 1 and R is 6. So L is 1 here and R is 6, right? R is 6. So we will again go and we will have to do the So let me just take this out so I can write down. So L is 1 here, so this is the first position 1, right? And 1, and R is 6. So see, this is 6, right? This is 6. As you can see, 1 2 3 4 5 6. So we have to do the summation of all these elements. So if you calculate the sum of all these elements, it is 28, right? 7 plus 7, 14 plus 2, 16 plus 2, 18 plus 4, 22 plus 6, 28. So we have to return 28 as our answer. So as you can see, 28 is the answer. Now this is the type 1 of the question, right? In type 2 question, we have to sort this array and we have to do the summation on the sorted array basically, right? So first thing is we will do is we will sort the array. So as you can see, this is the sorted array, right? This is the sorted array. And type 2 question is, let's say she has given us 3 and 6 as L and R. So let's just take L is equal to 3 and R is equal to 6. So 3 is this one basically, right? This is the 3, 1 2 3, and this one is the 6, right? So if we calculate all the sum of these elements, 7 plus 7, 14 plus 6 is 20 plus 4 is 24. So 24 should be the answer for that. So let's just check it out. So as you can see, 24 is the answer, right? So this is what the problem is. So there are two types of problems she will ask us, type 1, type 2. Type 1 is we have to do the summation on the original array that is given to us, and on type 2 problem we have to first sort the array and then we have to do the summation on the left and right, left to right elements basically, right? So let me just take out these colors now. So how we are going to solve the problem? The brute force way to solve this problem is you go through the array for these positions. Let's say you want to calculate from this to this, right? Then you manually keep calculating every time. You can go here, again you calculate. Next time if she asks you a question from here to here, again you go to this position in the array and again you keep calculating, right? But that is a brute force approach, right? So there is a better approach to solve this problem. So what we will do is we will calculate the pre-sum of the elements, right? Pre-sum means we will go through these elements once, we will iterate this element once and we will calculate the sum and we will store it in an array, right? That is called as pre-sum. So for example, 0 is the pre-sum first, then 6 came, right? So 6 is the pre-sum for this element. Now when we are at 4, the pre-sum will be 4 plus 6, which is 10 here, right? So 10, then 10 plus 2 is 12, then 12 plus 7 is 19, 19 plus 2 is 21, and 21 plus 7 is 28, right? So pre-sum we will store actually. So now when she asks us any type 1 question, let's say she asks us this type 1 question, for example 3 to 4. Now she asks us 3 to 4, right? So she gave L is equal to 3 and R is equal to 4. Then what we will do is we will just go to the fourth location. So fourth location is this one, right? 19 is the fourth location, and we will go into the pre-sum array to third location. So third location is 12. So 19 and 12. So we will just directly go and we will calculate, we will get 19 minus 12, right? 19 minus 12 is equal to 7. So we can directly calculate the answer here, right? We don't have to recalculate every time. So now you can see the answer is so basically 19. So 3 to 4, right? So 3 to 4, so 3 to 4 is let me just calculate this. So 3 to 4 we have to do, right? So 0 1 2 3 4 5 6. So 0 1 2 3 4 5 6, right? So answer is 3 to 4 is answer is 9, right? Oh, but that is a type 1, right? That is what type 1. So 1 to 6, let's say 1 to 6 is type 1, right? So 1 to 6, let's say. So you just go to this 6 element and 1 element, right? This is first and this is say 6, right? So it starts with 0 and it goes to 6, right? 0 to 6. So 28 minus 0 is equal to 28 minus 0 is equal to 28, right? So that is how we can directly calculate the answer So 28 is the answer here, right? And for 3 to 4 we will again go to the element now. So this is the 0 1, this is 2, this is 3, and this is 4, right? 3 to 4. So 4 minus 3, so 19 minus 6 plus 10 plus 2 12 plus 7 12 plus 7 19. So 19 minus 10, right, which is equal to 9. 19 minus 10 is equal to 9, right? So that's how we can get directly the answer. And if it is a type 2 question, 3 to 6, right, it is 3 to 6 question, then we have again we will calculate a Presum array for after sorting, right? After sorting we will calculate a Presum. So 0 to 2 is 2, right? So 0 to 2 is 2, then 2 plus 2 is 4 here, right? Then 4 plus 4 is 8 here, 8 plus 6 is 14, 14 plus 7 is 21, and 21 plus 7 is 28. So we will again calculate the like Presum after sorting, right? So we just calculated Presum after sorting, and now we will go 3 to 6, right? So 3 to 6 we have to do. So this is 6, this is 5, right? This is 4, and this is 3. So 3 to 6 will be for type 2, right? 3 to 6 will be 24. So 28 minus 4, right? This is 3 basically, and this is 6. So 28 minus 4 is 28, 24 basically, right? 3 to 4 means this is 3 actually from starting, and that is 6. So this is 1 2 3 4 5 6. So as you can see here, if we are calculating for 3 to 6, right? So here it is 2 and 3, 3 to 6. So left is 3 and right is 6, R is 6, right? So 3 is the Presum for 3 will be 4 and Presum for 6 will be 28. So 28 minus 4. So it will be 24 basically. So that's how we will get 24 as the answer, right? So let's just go ahead and let's just look into the implementation for this problem. So as you can see, I just have this couple of variables n, l, r and r for the same example, and this is the type 1 problem, and this is the array that is given to us. So we'll just first calculate Presum basically, right? So Presum start with 0 and it will go until n plus 1, right? So we are just doing two Presums. One is without sorting and one is after sorting, right? So Presum we will calculate. So this one is the Presum first, right? So Presum I minus 1 plus I array of I minus 1, right? Presum of I minus 1 plus array of I minus 1. Similarly, after that we will sort the array and we will calculate Presum after sorting, right? So after sorting also we have Presum like this. This is Presum after sorting and this is Presum before sorting, right? So this is Presum before sorting and after sorting, right? And after that, if it is a type 1 question, we will just do Presum of r minus Presum of l minus 1 we will do, right? L minus 1. So that's why it works, right? So Presum of r, for example, if it is a, let's take this example, right? This example we will take 3 comma 4, right? 3 comma 4 we will take. So L is 3 and R is 4, right? R is 4. So we will take presum of 4, which is this one, right? Presum of 4 is 19. So this is 0. So this is 0, 1, 2, 3, 4, 5 and 6, right? So presum of 4 is 19. So we take 19 minus presum of L minus 1. So L minus 1 is 10, right? So 10. So 19 minus 10, which is equal to 9, right? So 9, that's why the 9 is the answer, right? So as you can see, 9 is the answer, like that basically. And for the 1 to 6, if we ask 1 to 6, then we will just go presum of 6 is 28 and presum of 1 minus 1 basically, which is 0, right? Presum of 1 minus 1 is 0. So 28 minus 0 is equal to 28, right? So this is the presum of this 28 is the answer for that, right? So similarly, if it is a 236, right? 236 means type 2 problem. So type 2 problem. So this one, right, we will use, and 3 comma 6. So L will be 3 and R is 6 for type 2 problem. So we will go and we will take the presum of 6 is this one, right? This is 0, 1, 2, 3, 4, 5 and 6. So the 6 will be 28 minus presum of 3 minus 1, which is 2, which is 4, right? 28 minus 4 is equal to 24. So 24 is the answer for that one, right? 24 is the answer, right? So this is how the presum work, right? So presum is, we are going to just calculating the presum as I explained, right? We will go from beginning and we will create one presum array and we will sort the array, and again we will create a presum array after sorting. So we can directly answer by looking at the presum array. We don't have to again calculate the sum basically, right? That is the important part of this question. So here, as you can see, whenever it is a type 1 question, now we can directly answer the presum of R minus presum of L minus 1. And if it is type 2, we will take the presum after sorting of R and minus presum after sorting of L minus 1, right? So that is the only difference. So in the second question, we have sorted the array before taking the presum after sorting, right? So we can just run this example of 3 comma 4. So we are running this example, so we should get 9 as our answer. So let's run this code quickly and make sure it works. So we are getting correct answer 9. So we will check with this 1 comma 6 now. So let's just modify this. So L is 1 now and R is 6. So now we should get 28 as our answer, right? 28 as our answer. So let's run this one. So we are getting correct answer again. So now let's run a type 2 problem, right? Now let's type 2 problem, let's run. So type 2 problem is this one, and here 3 comma 6 is given. So L is 3, R is 6. So L is 3 here and R is 6 here. So now the answer we are expecting here is 24. So let's run this code and make sure it works. So 24 is the expected answer, which we are getting correct answer here. So this is the way we can solve this problem, Kuriyama Mirai stones on Codeforces. So one more time, like I'll just remove this coloring so we can summarize how we solved this problem. So what we did is we first calculate the presum of this array. So this array, this is the so for this array we calculated this presum, right? And how presum is calculated? 0 is for 0 it is 0, and then we will keep adding this, like 0 plus 6, then it becomes 6, 6 plus this 4, then it becomes 10, 10 plus this 2, it becomes 12. So like this it will go on, right? So like this presum we calculated, and whenever a question is asked, we can just use that L and R minus R and L minus 1, right? So if the question is type 1, right? This is for type 1. So if it is type 1 is 3 comma 4 is given to us, let's say L is 3 and R is 4, R is equal to 4, then we just directly go to the fourth position, right? The position start with 0, so 0, 1, this is 2, this is 3, this is 4, this is 5, and this is 6, right? So we directly go to the fourth position. So fourth position we got 19 minus, we go L minus 1 basically, right? L minus 1 is 3 minus 1 is 2, right? So 2 is here, right? 2 is here. So 19 minus 10 is equal to 9. So this is what answer is, right? After the pre-sum is calculated. And why it works? Because we know that the sum at this point is 19, right? And sum at this point is 10 basically. So if we subtract it, then we know what is the sum between L and R basically, right? Between L and R, how many is the sum? So that's why pre-sum works, right? So we know the at the fourth point the sum is 19. We know the sum at point 2 is 10. So it means that between 2 and 4 the sum will be 9 basically, right? That's why pre-sum works. That logic works. So same logic for the type 2 question. The only difference is we have sorted this array and then we calculated the pre-sum, right? After sorting. So otherwise logic remains same. So this is the way you can solve the Kuriyama Mirai stones problems on Codeforces. If you haven't already looked at my playlist on my channel, there is a playlist called as Codeforces as well as Leetcode and Leetcode solutions. And those playlists have over 200 solved coding problems which were taken from big tech companies interviews such as Amazon, Apple, Microsoft, Facebook, Google, Yahoo, and many other big companies. And those are selective problems which are important to cover the varieties such as graph problems, binary search tree problems, dynamic programming related coding questions, as well as BFS, DFS matrix problems, optimization problems, priority queue problems, linked list and string related coding interview questions are also covered there. If you are simply preparing for telephonic or initial screening, there is Java interview playlist that covers frequently asked telephonic questions and how to answer them. If you like this video, if you find it helpful how it is explained with examples and Java code, please hit like and subscribe it. Your subscription is really important for the channel because that is the way the channel can reach to more people who need help while preparing for coding interviews. They can also see these solved problems and understand and learn the techniques and what data structures to use and how to approach different varieties of or problems. They can also learn from seeing these videos, because the main goal of the channel is to help people who are preparing for coding and Java interviews by providing them coding questions and explaining them. So please subscribe to the channel, and if you like this video, please share it with your friends and colleagues, and thanks for watching this video.